When we think of peak human engineering, we picture the microscopic. We measure our greatest achievements in nanometers and microns, the invisible tolerances that make modern processors function. We often assume the distant past was the opposite, an era defined by brute force, massive manpower, and blunt instruments. The Giza Plateau is often presented as the primary monument to this era. The standard historical timeline attributes these massive structures to the use of copper chisels and stone hammers. But our modern bias might be blinding us. Because we strictly equate advanced capability with electricity and digital circuitry, we overlook the physical evidence of an ancient industrial reality. When you apply modern mechanical engineering audits to these artifacts, the physical measurements contradict the accepted historical narrative. This discrepancy was first documented by early archaeologists like Sir William Flinders Petrie. His surveys of Giza in the late 19th century recorded block joints that fit together with optical precision. Today, master machinists have audited sites like the Serapeum of Saqqara. Inside these tunnels sit massive granite boxes exhibiting optical-grade flatness. We are looking at surface tolerances accurate to 1/10,000th of an inch. Where these multi-ton lids meet their bases, the seams are tight to within 1/50th of an inch, creating a seal that is functionally airtight. In modern engineering, achieving a tolerance of 1/10,000th of an inch across a wide surface requires a controlled mechanical environment. If these stones consistently show these measurements, the methods used to create them had to move past individualized craftsmanship and into a realm of standardized mechanical production. The official report of Egyptology states that these structures were carved using soft copper chisels and diorite pounding stones. This chart shows the Mohs hardness scale. It represents a basic law of material science. A harder material scratches a softer one. Here, copper sits near the bottom. Rose granite contains quartz crystals, ranking much higher, surpassing copper and iron. A copper blade cannot cleanly slice through quartz-rich stone. The physical friction would destroy the tool before it made a significant mark. Material science suggests the accepted toolkit was physically capable of producing this work. If the tools we found don't fit the evidence, we have to look at the manufacturing waste, the leftover tool marks and discarded drill holes scattered across the manufacturing sites. Researchers from the Penn Museum took silicone molds from the interiors of ancient basalt drill holes. The resulting castings revealed deep, continuous, concentric grooves carved into the hard stone. Notice the even spacing between these rings. In machining, this distance determines the feed rate, the exact amount of material removed with every single rotation of a drill. Maintaining a feed rate this deep and consistent requires immense downward pressure and high-speed rotation. This is a pattern left by machinery, not by hand-turned manual drills. This cross-section shows the Great Pyramid's internal layout. Viewed through modern systems architecture, it resembles the logic pathways of a printed circuit board. The exterior is local limestone, but internal chambers use imported quartz-heavy granite. Quartz is highly responsive to acoustic energy. Measurements inside the king's chamber reveal that its dimensions turn the granite room into a tuned resonant cavity, naturally amplifying frequencies at exactly 110 Hz. The builders used 6 million tons of quartz-heavy granite to create a chamber that amplifies sound into a steady 110 Hz vibration. In this configuration, the internal architecture functions as a massive resonance system. If you trace the timeline of Egyptian construction, you do not see a slow, steady improvement. You see an engineering spike that occurred during the earliest dynasties. The oldest structures feature flawless, optical-grade stonework, but in monuments from the later Middle and New Kingdoms, the masonry is sloppy. The stones are smaller, the cuts are uneven, and the walls are crumbling. The technology devolved. Later pharaohs inherited these structures and claimed them, but they lost the capability to replicate the engineering. We separate our world into analog and digital, but the original builders achieved modern manufacturing tolerances through a mastery of material science and mechanical friction. Human progress is not a guaranteed upward line. We are not the first people to engineer at this level of precision. And the ruins left behind suggest that no matter how sophisticated a society becomes, its most complex knowledge can be forgotten.